Today we're talking about OpenCL. First of all, what is OpenCL? It's a framework for writing programs that execute across heterogeneous platforms. For example, CPU, central processing units, or GPU, graphics processing units. And we're going to look at how this is implemented as an example on Mac, Xcode. First of all, when you create one project and you need to double click the target, and then under this link binary with libraries, we're going to add and search for OpenCL. It comes by default on the Macintosh. Make sure it's added here. And we go back to our code. So in this example, we're doing a data computation of squares. So we have a 1024 sized data of 1024 bytes, and we want to get a square out from it. And this is to declare the kernel source. And the basic process consists of setups, compilation, and then the enqueue writes. For the setups, we get the devices, create a context on that device, be it CPU or GPU, and then create command queues. For the compilation, we create a program, build a program, and create kernels. And let's take a look at the example. These are the definition on it to declare the variables. So for the first step, we're going to connect to a device. We can connect to a GPU, if so. Otherwise, we can also connect to a CPU. And the second step would be to connect the context with that device ID, which we declared in the first step, and then create a command queue, and then to submit the work using that queue later on. The next step is to create the program from the source buffer, the context, which has the one we specified which device to compile for, and then a pointer to the source code. Next, we're going to build the program executable and start the compilation, or rather we should say lazy compilation. Usually the first one takes the longest time, so it's going to go around the queue, which we're going to see later on. And now we create the kernel that we wish to run this square, and then the kernel is going to submit to the GPU or CPU device that we have. And then we create the input and output buffer in the device memory. So we have this context for the buffer memory object, and with that we get to know that where the data needs to go, and we also need to specify the property of the buffer, which is read only, write only, or read and write. And then the next is to enqueue the writer buffer to write our data set into the input array in device memory. So we put the data in the buffer to our device using this command, and input will be our buffer, and this is the size of the data and a pointer to the data on the CPU, for example, and then we copy the data from the CPU to GPU later on. And if we enqueue it, then we're going to go through the queue one by one and execute at some point. And next, this is for set arguments, and then we get the maximum work group, basically the maximum size. And now we get to the enqueue ND range kernel. ND stands for we want to be a one-dimensional global input dataset. And last but not least, we have to use this command, cl finish, because this is a asynchronous operation, so it needs to wait for everything to finish. So we're gonna need to finish the commands. And that's basically it. And then we just print out the result. So let's execute this one. It's saying could not launch because it has no error string. And don't panic. This is where we go to this targets, double click, and there's a compile source. And you can add, if you want to run this one, you can add this program. And sometimes when you run like a few programs, this part is static, so you have to delete one, or otherwise if you have two programs here, it's gonna give you like duplicate error. So I have to make sure the compile source only has one program that you wanted to execute. So now let's execute this one, and it's getting the 1024 correct out from the total numbers count. And also, if you want to compute this from the command line, and we just do clone OpenCL main, and output is m, and we're gonna get the same result. Hope this is helpful, and leave any comment if you want any improvements or any suggestions, and see you next time.